Myself Sheikh Naim. So today we are going to see a continuity equation problem by computational fluid dynamics. Here we are specifically using ANSYS software. In ANSYS we are using the Fluid Flow Fluent module. So for this one I will consider a problem from the fluid mechanics textbook. If you see we have a problem like this. uh, Water is entering through a pipe where inlet diameter having 10 centimeter and the outlet diameter having 15 centimeter, and water is entering with a velocity 5 meter per second. So here we need to calculate exit velocity, that is v2, and we need to calculate discharge through this pipe. So this problem was solved numerically. So if you see here, so area, if you calculate pi by 4 d square, so d value is 10 centimeter at the inlet, it gives rise to 0.07854 meter square. And similarly, if I calculate area at the exit, because I already know the exit diameter, which is 15 centimeter, so I substitute here, I will be getting 0.01767 meter square. And if I use area into velocity, I will be getting discharge value, that is 0.03927. And if I use into these discharge value or A1 V1 into my continuity equation, everyone knows this is the continuity equation. If I substitute the values at here, I will be getting my exit velocity, which is nothing but 2.22. So in this today's lecture, we try to find out what is the exit velocity if you solve this problem in the ANSYS Fluid Flow Fluent. So we will open our ANSYS software. So here I already said we try to open Fluid Flow Fluent here. So this is not a 2D problem. We try to solve it is a 3D problem. So we will right click on geometry. So first we'll go to design modeler geometry. Okay, I try to open design modeler geometry. So this is my design modeler geometry window. Here, if you see the problem, so here I want to draw this diagram, this pipe I want to construct, I want to draw in my fluid flow fluent. Then what I need to do here, so first I will consider the units. It is convenient me to consider units are centimeters. Okay, so I will be considering units are centimeters. Then I am going to select my plane is XY plane. I want to construct my diagram in XY plane. Then I have an option at the top. You can see look at face or look at plane or look at sketch. When I click that one, this view will be converted into orthographic view or convenient sketchable view. Now what I'm going to do, so I will go to sketching here. Left side you can see there is a sketching option here. I will go to sketching. Then if you see clearly this diagram, see how I'm going to draw this one. So first what I will do, I will take, so I will consider a axis here. I will be considering a axis. Then I will draw a vertical line which is at a height of, this height should be 5 centimeters. We'll construct this one as 5 centimeters. Then I will draw another vertical line, so which is having a height of uh, so it is diameter is 10 centimeter, but I'm taking axis symmetric model. For that reason, so I'll be considering this is my 5, and this should be 7.5. So I'll be considering this height should be 7.5, which is nothing but half of 15. So then I will join these two inclined, sorry, these two vertical line with a inclined line. Then I will join these two vertical line at the bottom with a horizontal line. This is how I can finish my first part of my modeling. Later what I'm going to do, I try to revolve this part. If you see, So this is my first sketching. I try to revolve this one around the x-axis such that I will get my three-dimensional or 3D model. So I will do now. You can see now. So first I am going to what I'm going to do. I am going to construct a vertical line here. You can see I will be constructing a vertical line. Then I'm going to construct another vertical line. You see here, I'm going to construct another vertical line. Then what I'm trying to do, I try to join these two vertical lines with inclined line at the top and these two vertical line. See, when I need to select this point, see there are two points are displaying. One is C, another one is P. So C is on x-axis, P is onto this line. So you need to select the P, not the C. Okay, try to remember that one. So I'm going to select the point at the bottom and I'm going to select point at the other vertical line bottom. Now these two are joined together with the horizontal line. So every time whenever you try to draw any diagram in the ANSYS, that should be a closed profile. Then only you will get the output. Otherwise, you'll be getting some error. Now, what I'm trying to do, I try to give a dimension. So for that reason, you have a dimension toolbar here. You directly select general. So you see, when I select general here, when I try to give dimension for this vertical line, I simply select this vertical line. I will drag my dimension at the left side. Then I will select the other vertical line. I will drag my dimension at the right. Now I try to drag so that I was dragging, I was selecting the left vertical line. I'm giving a dimension at left side. I selected right vertical line. I given a dimension at the right side. Now those values are seen in the details view. This is called details view, where you can see or you can change the values of the V1 and V2. So I already said V1 is nothing but 5 centimeters and that V2 is nothing but 7.5 centimeters. You can see because I was selected centimeters, then only I will be getting here units are centimeter. The next part, if I see here, then what I said, I need to rotate this one along the x-axis. So I'm going to rotate this one. So I have a revolve option. If you see here, I have a revolve option at the top. When I click revolve, it is asking two things. So first it is asking select geometry. What I'm going to do, I will go to XY plane plus symbol because there I have a sketch. If I select this sketch, so this is nothing but our sketch one. Then I click on apply. Then it is asking axis. Okay, when I select this one, so I need to choose axis. So I'll be choosing this x-axis is my axis. You can see this is axis I was choosing. Then click on apply. Now you can see the angle, there is rotation angle. So I will be giving as 360 degrees because I need complete pipe here. So for that reason I was chosen 360 degrees. Then I will click on generate. You can see a complete three-dimensional pipe was generated. So at the inlet it is 10 centimeter, at the outlet will be having 15 centimeter. So if you see here in the part body left side, you see here you have a part body. When I click on solid, so it is showing me a solid at the bottom. You can see whatever solid I was created, default it is a solid, but I want to do fluid flow analysis. I need to change it to fluid. So I'll be changing into fluid here. Then click on generate once again. Then close this geometry window. So this is called geometry window. Then after that, I will be in the see. You can see a geometry window was given a tick mark. So that means I was finished with the geometry. So it is given a green color tick mark means I was generated geometry without any error or without any uh, lack of points. Then I will double click on mesh. Now you can see this is the mesh window. So if I go to geometry, if I select solid, so it gives me fluid only. Okay, you can see because we changed their solid to fluid, it was reflecting in the mesh window. What is my next step? So this is a simple problem. So we'll be not using any element size here, number of divisions. I will simply go to mesh, right click here and generate mesh. I will be generating a default mesh here. So this is mesh was generated. If you want to know data related to this mesh, at the bottom we have a statistics. Here you can check how many nodes it was generated, how many elements it was generated. So it is a, I said it is a simple problem. So we need not to bother about the number of divisions, element size. In later sessions, we will see in detail about number of divisions and element size. Okay. Now what I need to do, I need to create a named sections here. So I will going to select first face selection option. You can see. So this is the option where we can only select faces. Okay, we can only select faces. You can see with this option we are selecting only faces. Or if I want to select only edges, you can see this is the edge selection option. I will going to select only. See when I'm clicking on faces, it is not happening. But when I click on edge, it is going to select. See when I'm trying to click on, it is selecting edges only. So I need face selection. So I'm going to see face selection here. I will select left face, that is my inlet. Right click here, then create named selection. Give name of the faces as inlet. Then select the outer face. So this is my outer face. You can clearly see this is the outer face of my pipe. I will right click here, create named selection. I will be giving as a wall. Okay, then so this is my outlet. So I will be selecting this face. Right click here, create named selection. It is my outlet. You can see. So you can verify once again. Uh, with the help of pan, I will be adjusting my diagram. Okay, I will be rotating into my convenient way. So in the named selection, you can see we have inlet. You can clearly see. So this is your inlet and this is your wall. You can see complete outer surface of the pipe is a wall. Then you can see it is your outlet. Okay, this is how we can finish our meshing. So I'll once again click on generate. Then I will close this window. So here you can see uh, we finished with meshing, but still some update is asking in the meshing window. So we will right click on mesh and click on update. So some update it is going to ask after finishing your or after closing your meshing window. You can see you can easily track the progress at the bottom. Okay, you can see this is the progress. What is happening to your project or your problem? Everything is available at here. You can see any errors. You can see progress. You can job monitor anything. You can see at the bottom. Now I will double click on setup. You can see it is asking a option. So we need precision. So I need definitely a double precision. So I'll click on start. Okay. Now you can see this is our setup window. So if I double click on general, so this is the general. Here our problem is incompressible flows. So for that reason, I will be choosing pressure based. So I'll be using absolute and steady state. Okay. Then I will go to model. Here we have a options like multi-phase, but we will not bother about those all other options because it is our first lecture. So we'll see step by step all these options. So I will double click on energy. So I need to give a tick mark for the energy. So I'll be giving tick mark for the energy. Then so in viscous, you can see this is a viscous. So I'll be choosing a turbulent model, A omega. So is that a turbulent model? I will be choosing a turbulent model here. Click on OK. Then come to materials. Here we have options are there. So we go to fluid. When you double click on air, so it is showing a window. You can clearly see it is showing a window. Here, what my intention is, if you see the problem, here water is flowing, not the air. So I need to add water to my uh, material. So I will go to Fluent database. In Fluent database, if I scroll down at the bottom, there is a water liquid is available. You can see water vapor is also there, but I need water liquid. So you click on copy and close. Then again you need to click on change and create, then close. So if I go to fluid now, previously it is air. If you observe clearly, so previously only air is available. Now you can see air and water. Now I am trying to give uh, my fluid for my problem is water liquid. Then I go to cell zone condition. Here I try to define the material or the throughout the this pipe. I try to define as a water. Default it is a air, but I want to convert it into water liquid. So don't worry about the zone name here, because we are not changed the name in the geometry window. Whatever, if it is mentioned solid also, but here we are changing it to water liquid, or we already changed in geometry to in geometry window solid to fluid. Okay, don't worry. Then click on apply, then close. Then then we come to boundary condition. At left hand side you can see this is very important, boundary condition. Now, so whatever named selections we given in the mesh, same thing, or it is visualizing it here. We'll select inlet. At the bottom you have a type is called velocity inlet. So I definitely need velocity. Click on edit. Here I want to give my velocity magnitude is 5 meter per second. I will be giving velocity is 5 meter per second. Apply, close. Then I will directly go to a reference value. In reference value, I try to give compute from inlet, because I am starting from the inlet. So I'll be giving compute from inlet. Then I will go to initialization. At the initialization, there are two options are there: hybrid initialization, standard initialization. Don't worry about these two. We will see these two things in detail in upcoming lecture series. Okay, just we'll select hybrid initialization, initialize. Okay, then we'll go to run calculation. So in run calculation, it is asking number of iterations. You may give, if your problem is very complex, you try to give many iteration, but my problem is very simple. I will try to give only 100 iterations. Then click on calculate. Now you can see so your calculation is very fast. So click on OK. Then so I want to visualize my result. For that reason, so this setup is not convenient to visualize our result. So I will close this one, my setup window, then click on OK. Okay. Now we'll go back to the setup is also over, solution is also over. Then we open our result window. So I'm trying to open my result window. Here, this is our result window. You can clearly see. Now, what I'm trying to do, I will first, these are the wireframes. So first I will off this wireframe. At left side, I have a wireframe option. When I deselect this one, these wireframes will vanish. So first I will go to contour. Okay. Then I try to see variable is a velocity. So this is my velocity. Then I need to see location. So we have a different locations are there: inlet, outlet, and wall. I will click on OK. Then I will be using number of contours are 500. Click on apply. You can see. So you can see clearly. So our inlet velocity, this is inlet velocity. It was represented with a dark red color. You can clearly visualize here, which is nothing but 4.950. It is approximately 5 meter per second. You see the blue color lines nearer to wall, they are showing a zero velocity. You can clearly see from the velocity contour, the velocity at here it is zero. That means nearer to your wall, the velocity is always zero. Now, then if I want to see here, this color, you can see this color is matching it here. This is approximately 2.23 or 2.6. If I average it, it is around 2.4 or 2.5. You can see. So that is nothing but 2.5 or 2.4. So whether it is matching with our problem or not, you can see. So you clearly see the outlet velocity, which is nothing but 2.22 meter per second. It is approximately matching. See, whatever we done now is simulation, which is approximately matching with this the value 2.22, which was obtained from the numerical way. Okay, so this is how we will close today's session. So I hope everyone understand and you can able to perform same thing in the ANSYS Fluid Flow Fluent. Thank you.